Now that we've gone over how to write an expression for Q and K, remembering that Q tells us that the reaction is anywhere besides equilibrium, and K tells us only when the reaction is at equilibrium, we now need to discuss the interplay between Q and K. So if we're met with a reaction and we are told that the initial concentration of A is 10 molar and the initial concentration of B is 5 molar, what we should do is write an expression for Q. So remember, this is our initial values. So if they were to specifically tell us that these are not the equilibrium values, rather these are our initial values, and we're going to let this reaction run to equilibrium, that is a clear sign that we are dealing with Q. So Q is going to equal products over reactants. I should make sure to check that these are not solids or liquids, which they're not. If it's a gas or aqueous, we can include it. So these are both aqueous. So I'm going to write this concentration of B over the concentration of A squared because of this 2 in front. So remember to include that. So we can actually solve for Q here. Q is our initial value. So the concentration of B is 5 and the concentration of A is 10 squared. So this is 5 over 100, right? And this is going to be equal to 0.05. So Q is 0.05. Now, what happens if a question or some given scenario has the value of K equal to 2? So we'll say the products over reactants, which is still equal to B over A squared, because Q and K are the same expression. But instead, what we need to find is one of these concentrations. Maybe we want the concentration of B at equilibrium. If we are given the K value, maybe the K value is 2. We know a lot about this reaction now that we have an expression for Q and for K. So what I like to do is I like to draw a number line to see what we're dealing with. So if we continue this on to the next page, if this is 0 and we cannot have a Q or K value lower than 0, because at that point you would have a negative amount of something, which isn't possible. So 0, it is possible to have a Q of 0 if you don't have anything, but that's why you start the number line at 0. And let's call this 10. So this is 1, 2, 3, 4, 5. Okay, so at this point, Q is right here. Q is at 0.05. And K is 2. K is not going to change. The only way that we could change our equilibrium constant K is with temperature, and we are not doing that here. So K is going to remain at 2. So what can we know about this reaction based on our Q expression and our Q value? Well, we know that this reaction, like any reaction, wants to get to equilibrium. Equilibrium is always the final goal. So what we can say is that Q will want to increase, in other words, catch up to K. So if Q was bigger than K, Q would want to decrease to get to K. But because Q is less than K, this reaction will want to make Q eventually equal to K. That is when we are at equilibrium. Q equaling K is equilibrium. That's when products over reactants for Q and K will be the same. So we will be, our snapshot in time, which is Q, will be what our K equilibrium constant is. That will be equilibrium. So in this case, Q needs to increase in order to catch up to K. Q is always just trying to catch up to K or decrease to get to K. So how are we going to do this? Well, remember that Q is products over reactants. So in order to increase Q, we should increase our products and decrease our reactants. That will make this fraction bigger. So if we look back at our reaction, this is really important information because a lot of questions and scenarios want you to predict which way will this reaction shift. Which way will this reaction shift? You'll see this word a lot, shift, meaning if you were to run this reaction, which way will it proceed? To the products or to the reactants? Well, in this case, Q is less than K, so Q we need to make bigger to catch it up to K, so we should make more products, increase this fraction right here. So what we can say is we will make this reaction go towards the products and make B to increase Q. So this is a really important concept you need to get down, which is equilibrium, and separating equilibrium from where we are in the reaction right now. So just to summarize what I went over, we solved for Q, we solved for K, we saw that Q was less than K, so we want to increase Q to make it equal to K. That is what equilibrium is, and the way we're going to increase Q is by increasing the products, shifting this reaction to the right. We want to run it in the forward direction to make B so that Q can be happy and be equal to K. So in the practice quiz after this, I'm going to put some examples on how you should get Q equal to K. So make sure to go through those slowly and really understand them.